morning, grade 8 students of Somerset Intermediate, and welcome to your Reachback 5 answer video. I don't know about the rest of the grade 8 teachers, but I know with my grade 8 students, I'm getting a lot less passing in a picture of their work on Monday. I think this time I only had maybe half of my students pass in a picture of their answers, so please try to make sure you get the work done. It's not a ton of work. It's just a little bit of work to keep you guys on task and remembering what it was you were learning before the quarantine. So we'll start with question number 1. And it says, who ran faster, Mr. McDonald or Mr. Coyle? So if we look at this question, Mr. McDonald, oh, what a good looking picture of Mr. McDonald. And he ran 50 meters in 12 seconds. Or Mr. Coyle ran 64 meters in 15 seconds. Now, in order for us to compare who was running at a faster rate of speed, we have to use unit rates. So our choices for Mr. McDonald are we can figure out how many meters did he run in 1 second, which would be a unit rate, or how many meters did he run in 1 minute, which would also be a unit rate, because in both of them, the second term is 1. We could also do per hour if you wanted to, but the easiest ones would be one of these two unit rates. So we're going to choose how many meters in 1 minute. Now, if he ran 50 meters in 12 seconds, then what we need to do is we need to set it up as a proportion of rates. So therefore, if he ran at that constant rate of speed, how many meters would he run in 1 minute? Now, of course, 1 minute can also be thought of as being 60 seconds, which is probably more appropriate, because if we go back one here, if we have seconds as the bottom term in our first rate and minutes in the bottom term as our second rate, it's a little bit confusing. But if I change minutes to seconds, then it's much easier to do, because now, in order to keep it proportional, we need to multiply both terms in our rate by 5 to create a proportional rate, which means that Mr. McDonald would have run at that constant rate of speed 250 meters in 60 seconds, which we can write as 250 meters per minute. Okay, so we'll go back here and we'll put that in for his rate of speed. And we'll do the same thing for Mr. Coyle. If Mr. Coyle ran 64 meters in 15 seconds, then we start as a rate of 64 meters in 15 seconds. Then we can change that to a unit rate by figuring it the same way we did with the last one. Multiply both this time by 4, because 15 times 4 is 60. And when we do so, we get 256 meters per minute, which means his rate of speed is this. So if we compare the two, Mr. McDonald was able to run 250 meters in a minute, and Mr. Coyle 256 meters in a minute. So therefore, Coyle was faster. Our second question comes from Chapter 3 on Pythagorean relationship. What is the length of x? Now, obviously, we can do two things. We could either use a formula, which would be a squared plus b squared equals c squared, or we could do a picture. Today I'll do both in case you did either one, but it's up to you. So if I drew squares onto the sides of this triangle, because it's a right triangle, what Pythagoras said was the area of this square, since it's 36, its area would be 36 squared, plus the area of this square, since it's x, is going to be x squared, equals the area of this square to the square attached to the hypotenuse, which is 144 meters squared. So therefore, this area plus this area equals this area. Where 36 plus what equals 144. In order to do that, we can actually use subtraction. So if we take 144 and subtract 36 from it, we can borrow to get a 3, put a 1, we get an 8, and then we have a 0, and then we have a 1. So therefore, the area of this square is 108 meters squared. And therefore, if it's 108 meters squared, its side length will be the square root of that. So the square root of 108 would be its side length if I take the calculator. I go, what is the square root? Well, since we know the square root of 10, or 100 is 10, We can guess it's like 10.3 or 10.4. 10.4. So therefore, x is approximately equal to 10.4. Remember, you can use an equal sign with a dot above it, or if you'd rather, you could use x is wavy equal line 10.4 meters. There you go. That's one way to do it. The other way is using your formula. So a squared plus b squared equals c squared, or 6 squared plus x squared equals 12 squared. If we simplify our exponents, we get 36 plus x squared equals 144. And now we have an algebraic equation where x is on one side. We have a constant of 36, so what we're going to do to get rid of that is subtract 36. We get x squared equals 108. Oh, 108. And now it says x squared is equal to 108, but we don't want to know what x squared is. We want to know what x is, so we're going to square root both sides. The square root of x squared is x. The square root of 108 is 10.4-ish, approximately. So therefore, the length of x is approximately 10.4 meters. Question 3 comes from Chapter 4 on percents, which is grade 7. Which is more, 15% of 20 or 25% of 12? Now, there are two ways you can do it. You can use your mental math, or if you want, you can use a calculator. Okay, we're going to do both right now. So 15% of $20. Now, we know that 15% can be made by doing 10% plus 5%. That will equal 15%. Right, 10% plus 5%. So what is 10% of $20? You move the decimal one place. So 10% would be equal to $2 because you move the decimal place one place over. 5% is calculated by having half of 10%. So if 10% is $2, and half of that would be $1. And therefore, 15% is $3. So we'll put that right here. And then we'll do the next one. So what's 25% of $12? Remember, when we find 25%, we have to say, well, what's 50%? And since 50% is $6, because that's half, then 25% is half of that, and half of $6 is $3. So therefore, 25% of $12 is $3 as well. And it's a trick question. They're both the same. Right? They're both the same. So the other way we could have done it is with a calculator. And that's a little bit more tricky. But we'll look at it here. So the first question is 15% of $20. How do I do that with a calculator? Well, way back when, you learned that percentages were actually fractions out of 100. So 15% could be thought of as being 15 out of 100 because that's what percents were. And back in grade 4 or 5, you learned that 1500ths was written in words as 1500ths. And using place value, we would write it as tenths, hundredths, thousands. So 1500ths would be written as 1500 because this is the tenths position. And this one here is the hundredths position. And therefore, 1500ths would be written as 0.15. Now, some of you are going like, I don't remember this at all. That's okay. Just work with me. So 1500ths or 15% is written as a decimal as 0.15. The word of, you were told many times, can be thought of as the word as multiplication. So if I want to find 15% of $20, I can simply multiply 0.15 or 1500ths multiplied by 20. And when I do so, 0.15 multiplied by 20, I get the same answer I had before, which was $3. Now, if I repeat this process for 25%, 25 over 100 is 2500ths, which would be written as 0.25 as a decimal. So therefore, 25% of $12, if I bring my calculator up and ask it, what is 25 hundredths or 25% of $12? It will tell me 3 as well. So 2 ways to do it. You could have done it mentally, or you could have used a calculator. Whatever you used is fine. Question 4 is your surface area. Which has more surface area, cube A or rectangular prism B? Now, by now, you're probably getting used to using formulas. So if you are using formulas, what I'm going to do here is I'm going to write out the formula for a cube. And before I do that, I'm actually going to explain it. So if I think about the net first, I'm going to draw the net. We know that a cube has 6 faces that are all equal. So when I make the net of A, this is going to be the cube. Each of those faces is a square, and each square would have an area equal to its side length squared, because the formula for a square is side squared. So if I think about that, each of those faces would have an area of 36, because 6 squared is 36, and there's 6 of them. So 36, if I add them together or multiply, I can do either add them together to get an answer of 216 meters squared, or of course, instead of repeated addition, we learned that you can do 6 multiplied by 36, because we learned about repeated addition being multiplication. And either way, we get 216 meters squared. Okay, that's if you made the net. But an easier way to do that would be saying, what is the formula to calculate the surface area of a cube? And since side squared is one face, then if you take side squared and you multiply it by 6, or put a coefficient of 6, that would be the same thing as getting the answer here. So 6 faces of side squared would be 216 meters squared as well, because 6 times 6 squared is the same thing as 6 times, we'll do our exponents first according to bed mass, would equal to 16. Okay, so you could have done it like a net and got this answer, or you could have done it with a formula and got that answer as well. So the surface area of the cube A is 216. If we look at B, it's a rectangular prism, and again, if I was to make my net, it would look like this. But we could use a formula of 2 rectangles, which would be the front and back, plus 2 rectangles, which would be the top and bottom, and 2 rectangles, which would represent the left and right. And we can substitute all our information in there, and we could do this as well. So I'm not going to use the net this time. I'm just going to use the formula. If you use the net, that's fine, to see if you get the same answer. So if I think about the front and back, and I'm going to highlight the front of my net right here. This face is the front. And if I think, what is its dimensions? Well, these 2 numbers here, 10 and 5, are the length and width. So for this rectangle, I have 2 rectangles, both the front and the back, that are 10 by 5 rectangles. Right? The length is 10, the width is 5. For the top and bottom, here's my top. It is 10 again, but this time its width is the same as this one down here, which is 3. So I'm going to write down, there's 2 rectangles that are 10 by 3. And finally, the left and right, if I shade in this left one right here, it is a 3 by 5, because there's the 5 over there, rectangle. So I have 2 rectangles that are 3 by 5. And when I simplify this using bed mass, I'm going to have 2 50s, which is 100. And I'm going to have 2 30s, which is 60. And I'm going to have 2 30s. When I add them all together, I get 190 meters squared. So therefore, B, or the rectangular prism, was 190 meters squared. And therefore, the question says, which has more surface area? The answer is the cube has more surface area. Our question from chapter 5 on fraction operations gives us two questions, as which is larger, either adding those two fractions of 2/5 and 1/8 together or dividing them. So in order for us to figure it out, we can either use logic or we can use just solving the questions and comparing them. So let's just solve them and see what happens here. When you add two fractions together, remember what you have to do. You have to find a common denominator, which is the first multiple. Usually is called the lowest common denominator. So we use 40. You have to find equivalent fractions, which would be 16/40 plus 5/40. Once you have that, keep your denominator and add your numerators together, which gives us a final answer of 21/40. Okay. When we divide those two fractions together, let's change that 21/40. It looked a little wonky. When we divide them, you could find a common denominator and divide them if you want. But we found out pretty early on that the easiest way to divide two fractions is to multiply by what we call the reciprocal of the second fraction. So we can get the same answer this way. And when we do this, we get 16/5 as an answer, which is equal to 3 1/5. Now the question is, which one is larger? Obviously, this one is less than 1, and this one is greater than 1. So which one is larger? This. What's your reasoning? Because it's greater than 1. And 21/40 is not greater than 1. Question 6 comes from integers. Says simplify and rank these orders. So -1 plus -2. I'm just going to solve these real quick for you. When you add, combine, you get -6. When I do this one, 4 negatives and 2 positives is 2 negatives. Multiply together and same signs as positive. Divide and keep your sign. Divide is 2, positive 2. Simplify these and rank them in descending order. So your largest is C, your second largest is D, -2 is your third largest, and your smallest is A. Question 7, what is the 12th number in the sequence? What is the 10,000th number? That's a tough question. A lot of people got wrong. So if we look at this, I'm going to create a table of values, but instead of using X and Y, I'm going to use, this is a real tough one, N for the number in the sequence in the pattern. So N, and I'm going to use V for its value. Okay. Now, if you didn't do this, it ain't no thing, because most people forget how to do this, and it takes a lot of practice before you get pretty good at it. So we think about it. This is the first number, this is the second number, this is the third number, and this is the fourth number. And we're asked to find the 12th number, and we're also asked to find the 10,000th number. So we think about the number in the pattern, what we called N here, the first number, the second number, the third number, and the fourth number. Okay? The first number's value is 1. The second number's value is 4. The third number is 7. And the fourth number is 10. So take a time and copy down that table of values. Okay, that matches the pattern that we're given. Now, once we have that, we can say, okay, we're going to find the equation like we did in last week's Reachback by saying, what is the difference in, this time, V, which is going up by 3 each time, divided by the difference in X, which, of course, this time is N, and 3 divided by 1 is 3. So in the equation that shows the relationship between the number in the pattern and its value, our coefficient is going to be 3. Okay. Then we take any of our ordered pairs. I'm going to take 1, 1. And I'm going to substitute 1 for the N and 1 for the V, just like that ordered pair has. And I'm going to realize that in order for this to be equal, I need to have a constant of -2. There is the equation that matches the pattern. 3 multiplied by the number in the pattern, -2, will equal its value. So 3 multiplied by the second number would be 6, -2 would be its value. 3 multiplied by the number in the pattern, or 3 times 3, take away 2 is 7. And 3 multiplied by 4, take away 2 is 10. So now that we have that, we're going to take our 12th number. Ooh, that's not right. Our 12th number in the pattern. So 3 multiplied by 12, which is the 12th. Now I'm going to write my equation first, sorry, or my equation here. 3 multiplied by the 12th number minus 2 will be 36 minus 2, which will be 34 as a value. So the 12th number in the pattern will be 34. And finally, if I take this and erase it, well, I'm not going to have enough room, so I'll erase the whole thing. 3 multiplied by 10,000th number, or the 10,000th n, minus 2 will be its value, or 30,000 minus 2 will be 29,998 as its value. Okay, so if you didn't do it this way, don't worry. It's just a learning moment for you. Remember that tomorrow, Wednesday, you're going to have a pattern just like it. So if you use the same method, you should be able to figure out the answers to the pattern tomorrow. Question 8 comes from chapter 10. This is your last question on algebra. Which one has the largest value? So if we solve by inspection, 4 take away what number is negative 2? By inspection alone, 4 take away positive 6 is equal to negative 2, or 4 take away 6 is negative 2. If we think about the next one, 4 plus what is negative 2? 4 plus negative 6 is negative 2. Negative 4 times what is negative 2? Now, a lot of people probably have a lot of difficulty knowing that that is a half. But if we took our equation and solved it using, negative 2, solved it using opposite operation. Oh, that's the worst handwriting ever. X would equal 0.5. And finally, the last one, a negative quarter of what number? We're going to use opposite operation here. We're going to multiply both sides by negative 4. And X would equal 8. So if I think about that again, So if I think about that again, what number divided by negative 4 is negative 2? The answer, of course, is positive 8 divided by negative 4. So therefore, what is the largest value of X? Our answer is D has the largest value of X of 8. And that's it. That's all of your questions for today. So hopefully you made it to the end of the video. It's 23 minutes long. I know it's a long video. But if you're having difficulty with them, make sure you always press pause, copy things down. If you need to listen to the explanation again, or if it's not clear the first time, make sure you ask your teacher or ask myself. And if you ask your teacher, we can probably do another clarification video for you and do a couple easier questions. But remember, the answers to these questions will be used tomorrow in your video again tomorrow for your Reachback. So please make sure you keep your piece of paper and use it as a reference. And good luck to everybody. Stay safe and don't let your boomer parents drive you crazy.